Uh, is this thing on? Is it working? Hmm. Hmm.
Well, hi everyone. Welcome. We're going to be looking a little bit more at space, the final frontier today. And hopefully you'll learn something cool and new. I think you will. I'm kind of actually excited about this. And let's get right to it. Deep Space Part 2. Oh, yeah. All right. So last time we started talking about just like what is the universe, like how do we describe it with different words, words, yes, words. So words like stars, which we're familiar with, and galaxies, and just kind of like what is a galaxy. And then of course, celestial objects is a favorite phrase that we like to use in astronomy. It just means like anything in space, a star, a comet, a asteroid, a moon, etc. So today we're going to talk about the topic of how the universe began. Okay, so what we're going to be looking at is some ideas about that and also why those ideas exist. Okay? So the common phrase here is the Big Bang. The whole universe is in a hot dead spin. If you watch that TV show, I don't know, but so the universe began when an extremely dense concentration of matter exploded. Now, okay, it's kind of a little bit like I often read that. I'm like, well, yes. How do you know? And there's two answers there. Like on the one hand, of course, you don't know because like you weren't there. However, we can look at some things that maybe make us start to see why scientists are thinking this is the way it started. Okay, so the universe, we find that it is cooling down. So the temperature is decreasing, but it's not at zero yet. And it's expanding, it's getting bigger. Okay? So if you can imagine a graph of the size from beginning to present, what we find is that it's getting a little bit bigger as we keep going. Now, again, we've only had the means to measure this, relatively recently in history. So there's a lot of interpolation going on, but you get the idea. So we think that the size started smaller, and we can see now that it is expanding. So that's something that we can observe now. And then of course cooling. So if we picture that as a graph, so the beginning, if it's cooling, we started hot and we're going down. So what kind of relationship is that? I know you know. Right? So let's see. It's indirect relationship, right? The one is increasing, the other is decreasing. Okay, so that's all well and good to say that the universe is cooling and that the universe is expanding, getting bigger. What's like, why are we thinking this? What are the scientists saying that makes them think this? So there's a giant word here, cosmic microwave background radiation. Sounds like the name of a cool rock band. Cosmic microwave background radiation. Okay, we're not going to do that again. That was not very funny. But if we look at space and we measure it, I guess they go out there with a thermometer and they're like, open your mouth, okay. Where there's empty space, the temperature should be total zero. We call it absolute zero. It's the temperature 0 degrees Kelvin. It's like where everything stops moving completely. Nothing, not even inside at a microscopic level are any molecules moving at all. It should be absolute zero. Instead, we find that it's 3 degrees Kelvin, which is still extremely cold. That's negative 270 degrees Celsius. So it's still very cold. It's just that it's not what we expect. It should have been total zero, and instead it's at 3. This is making scientists think that, aha, the temperature must have been higher at some point and we're still cooling, heading towards zero. The other way, and this one I find to be a little bit more observable, is called the redshift of light. If something is moving away from you at a very fast speed, it will cause light to be bent, and it causes the light to look slightly red. You think of it like a filter when you're posting something on Instagram or whatever. Like some filters, like, you know, make it look totally different, but like this is just kind of making it look slightly red. So when scientists measure pictures from space and they're looking at a galaxy or a star and it's moving slightly away, it looks slightly on the red side. It's not like it's going to be totally red, but it's when you measure the light, you can see that it's towards the red spectrum. Whereas if it was moving towards you, it would be blue. So I'm just going to leave you with this. You've probably heard this phrase before somewhere. It's called the Doppler effect. And this is going to help us next time explain how we know about this redshift of light thing. And you can think of it like a car when it goes by you, it's like, right? And the noise changes as it's moving by you. And that's the sound waves being bent. In the same way, when a galaxy is moving away, right? When a galaxy is moving away, it's going to have bent light waves, and they're going to be shifted towards the red spectrum of the color. All right, we will talk more about this later, but thanks for coming in today, and nice short one for you. So Merry Christmas, happy birthday, whatever. Great. See you in class. Be there.